Hello. The LINEST function has 10 outputs. So we have this LINEST function of this data set, and we'll show the full statistics. And there are 10 outputs. Of the 10 outputs, we can easily calculate 4 of them, which are the intercept, which matches to our output. We can also calculate the slope. Also matches to our output. The R square, also known as coefficient of determination, correlation coefficient, square, and the calculation matches to our output, LINEST output, and the standard error of estimate, which is STEYX. Which also matches to our LINEST output. Next, we calculate the standard error values of the Y-intercept and the standard error values of the slope. To do that, we will need the Pijorina inverse matrix, where we'll use these diagonal values. We begin with the 1, x matrix, which is equal to array formula of the x values. Now that we have the 1, x matrix, we can now calculate the Pijorina inverse matrix, which is equal to minverse M mult transpose of this matrix, 1, x matrix, and itself. We have a square matrix that's inverted. Now we can calculate for the standard error value of the intercept, the Y-intercept, which is equal to STEYX times the square root of J2. And this matches to our LINEST output. Next, we calculate the standard error value of the slope, which is equal to STEYX times the square root of K3. And this matches to our LINEST output. Before proceeding to the last 4 outputs, we need the values of the following: the population, which is equal to rows of the dataset range. So we have a population of 9. Next, we calculate the DFN, degree of freedom of the numerator, which is equal to columns of the X. We only have 1 X column, so that is equal to 1. Next, we calculate the total sum of square, which is equal to N times the variance of population equal to N times the variance of the population, or the variance population Y. Now we can calculate the rest of the outputs. Next, we calculate the degree of freedom of the denominator, which is equal to rows of the dataset range minus columns of the dataset range. This is the degree of freedom of the denominator. Now that we have this value, we can now calculate the residual sum of square, which is equal to DFD, or degree of freedom of the denominator, times STEYX squared. STEYX to the power 2. And it is 8.8095, which matches to our LINEST output. Now we can calculate the regression sum of square, which is equal to TSS minus RSS. So that is total sum of square minus residual sum of square. So regression sum of square is TSS, total sum of square, minus residual sum of squares. Next, we calculate for the F statistics, which is equal to ESS divided by degree of freedom of the numerator. That's 1 because we have only one independent variable, divided by RSS divided by degree of freedom of the denominator. And the answer is 151.678, which matches to our LINEST output.